Hi everyone, Paul Mann here and welcome to my videos on Practical Python. In this video we're going to learn how to encrypt and sign documents with PGP and Python as part of my series on encryption with Python. Specifically we're going to use GnuPGP or GPG, which is essentially a free version of the commercial PGP and is part of the Open PGP standard. Alright, before we dive in here, we're going to decipher all of that to see exactly what we are doing, how we're doing it, and what we expect to accomplish. So let's first start with PGP. It was developed in the early 90s. It's currently owned by Symmetric and it is a commercial product. Before it was a commercial product, they had some issues with US export laws, so to get around that, they offered up the source code for free. Long story short, the Open PGP standard was created then to define formats for encrypting messages and signatures. GnuPG or GPG is a free implementation of the Open PGP standard that allows encryption and signing of data. GPG and PGP are essentially the same product, except GPG is free. They're almost identical, and this is the program we're going to use in our video here. So GPG is widely available and you can download it here. It works on most common operating systems and you will need to install this to follow along in this video. The next part of the puzzle is the Python library, which is GnuPG, and that is a Python wrapper that leverages the functionality provided by GPG. So for example, if you were comfortable with the GPG commands and you knew bash scripting for Linux, for example, you wouldn't need to use Python here. You could work directly with GPG. But we're using Python because we want to write our scripts in Python or we want to incorporate encryption into our code for applications. So here's how all these programs come together for our code. And on the top left, we have the Python libraries, and that's where we'll be writing our code. And the code will leverage the functionality of GPG, which will use the RSA algorithm to encrypt our keys and our data and sign it. And then we'll be left with ciphertext and digital signatures. So we could use other algorithms from RSA. The RSA algorithm is not part of the GPG program. The GPG program or PGP are not ciphers or algorithms themselves. They are programs or frameworks that help manage the encryption and decryption of data and keys and much, much more. So a quick refresher on public key encryption. Bob will send Alice his key, his public key. Alice will encrypt a document or a file with Bob's public key and she'll send that to Bob. Bob will be able to decrypt that file with his private key. So when Alice sends the document to Bob, she knows that only he can decrypt it because he has the private key that's associated with the public key that she encrypted the data with. Finally, these are the tasks we're going to set out to accomplish with our coding. We're going to generate keys, which is the first step of public key encryption. And we'll encrypt with our public key, decrypt with our private key. We'll import keys from other users, and we'll sign a document and verify the signature. So now that we have all the clarifications out of the way, let's install what we need to set up our development environment and start generating some encryption keys. Normally I use PyCharm as my IDE, but in this case, for illustration purposes, it's easier to set up two user accounts on a Linux system. So I'm using a Raspberry Pi and I have two accounts, Bob and Alice, and I'm doing it this way so I can show how keys are exchanged and encrypted with someone else's public key and signed and so on. But this will still work on PyCharm or any other IDE that you're using. I have Python 3.8 installed on this system and I'm about to install the GPG program with the app install. You can use app install to install the latest version of Python as well, which is recommended for this. Next we need to install the Python libraries, the GnuPG. And that's with pip3 command. And we need root access to run this, so I put the sudo in front of it. It's a pretty quick install. And then we're going to create a bunch of files in Linux here to write our programs. So I'm going to create a file for generating the keys, encrypting, decrypting, and signing. And it's just easier this way for illustration. You can, of course, put these files, some of them together. in your IDE, but I suggest you do this first till you get everything working. So in our first file, we import the library, and then I imported OS just as well. The third line is important because when GPG is installed, it creates a path, a home path, in the user's home directory called .GnuPG. And when keys are created in GPG, that's where they're put. They're put in this folder. So we'll need access. We need to know where that is so we can do various things, encrypt and sign and so on. So I put the coding as UTF-8. That's optional, but it keeps it a text. And the input data is the inputs that we put to generate the key. And you would normally do this at the command line if you were typing GPG, but we're doing it through Python, so we'll put the parameters in here, the name, the passphrase, the RSA, and the key length. We can put this to 496 or other lengths as well, but this is the one for here. And then when we input all of that, we run a routine which gives us the key, and the key is equal to GPG, and GenKey is the method that generates the key based on the inputted parameters that we put above. I put a print key just for sanity at the bottom so that we can print out the fingerprint of the key to make sure that it was actually created. And the key will be created, as I said, in the .gnup directory of the user's home directory. So let's run this and we'll see. So I'd execute a file at the command prompt, and the next we just simply type Python 3 first and then the name of the file that we created. This should be obviously in the directory of that file. And when we run this, there's the fingerprint. So that means the key was created. But we'll do an extra step here just to verify that the key. We'll run a GPG command. This is not a Python command. This is part of the GnuPG application that we talked about in the beginning. So the command to list the keys is GPG list keys. And as you can see, there's a private key created here for Alice at acme.org. So we've successfully created Alice's public key and private key. So when you run the gen keys, there's a key pair created. And this is important. So both of them are here. It says public key, but both the public and private are part of this key chain here. So now that we have our key pair, let's encrypt something. So I've created a directory on the Raspberry Pi called text files. And I put a text file in here just so we can encrypt. It's called debug. It's really just a debug file, but it's in plain text, as you can see. And that's the file we're going to decrypt with our public key. That's Alice's public key on the system. So we go back to the application folder, which I called PGP, and we'll bring up a file called PGP Encrypt. So in this file, the first few lines will be the same in all the files we created. We need to obviously import the library, but we also need to have the home directory for access to the keys. So this will be recurring in every file that we create. I'm also creating a variable for the path. This is just for convenience, so I don't have to keep typing it in all the time. And this is where the text files are that we're going to, the text file where we're going to encrypt. And I'll call the plain text file PT file, and that will be just the file itself, the debug file that we're going to encrypt. So before we can encrypt, first we have to open the file and convert it to bytes. And this is similar to what we've done in all the encryption videos. So we just put our two variables in there and open them as read bytes, RB. And now we can encrypt the file. We'll use the GPG method and use encrypt file. The status is the variable where the data will be returned. So we need the file itself. The recipients, in this case, it will be Alice at acme.org. It's her public key that we're going to use to encrypt this file. And I'll tell you the difference later between doing it with Alice's public key as opposed to her private key. But for now, we're encrypting with our public key. The output is the path where we're going to send the encrypted file. We could just put it back to the original file, but then you would lose the original file. So this is probably better for our purposes here. And then we're going to print out the status, make sure it's okay to decryption, and if there were any errors, the standard error method will let us know if we messed up somewhere. And this is important because sometimes the key is not imported or the key is not right, and this is where you'll find out these issues. So when we run this, we can see that we have the keys and the decryption started and ended. It was successful. And if we look in the text files now, we have a new file called debug encrypted. And let's use cat, the Linux utility. The original file is fine, still untouched. And the new file, cat debug encrypted, has been encrypted. So this was successful. We used Alice's public key to encrypt the file and rename it as the file name plus encrypted. So now let's decrypt it. We'll use Alice's private key to decrypt it. So we'll create a new file called PGP encryption. Again, I'm just pasting all the pertinent information. We need to change the plain text file to the encrypted version because that's the one that we encrypted. Everything else should be the same. So now we're going to open up the encrypted file so that we can run it through our method and decrypt it. In this one, we'll see that we need to put our passphrase because we're using our private key, or Alice's private key. So it's a little different decrypting. We put the file name, we put the passphrase, and again, we put the output as decrypted. So it'll be a long file name now, debug encrypted decrypted. But the key thing here is that the passphrase for the public key has to be put in order for Alice to decrypt with her private key. When we run this, we see the key that was used. We also see that it was good. It decrypted everything, no errors. So now if we look at the encrypted decrypted file, we should have the original text. And there it is, successfully decrypted with Alice's public key, or private key, sorry. So now let's see how we can encrypt multiple files at the one time. So in my text file directory, I put a bunch of text files. They're actually Java programming, but they're all text, and they're all in the text file directory. So we're going to encrypt all of these at the one time. It'll be kind of like a ransomware attack on my directory because we'll encrypt them and not change the name, the output name, which means that the actual files themselves will be encrypted. So we'll see how that works. We'll create a new file, and this time we'll call it encrypt multiple, and we'll paste in the usual stuff. But this time we're going to use the OS list directory, and we're going to loop through the files in the text file directory. And for each file in that directory, we're going to encrypt it with our public key, or Alice's public key. So we just have to put a slash after the path to get everything in the directory. We'll use the status again and use GPG, encrypt files. You can just encrypt data too, but we'll encrypt files. And for every file, as we loop through it, we will get the recipient's key, which in this case is Alice's public key. And we'll set the output at the same as the input, essentially path, just the name of the file. So we'll put the usual alerts with status OK, or status the standard out error, to make sure that there are no issues with the encryption. When we run this, we will encrypt every file in that directory. So like I said, it's a It's an example of a ransomware attack. If you just run this on one directory, you can see everything is there. It was quick. And now we go into that text file directory, and all the files are there, still the same name, but the difference is that when we cat the contents, they're all encrypted. And there's no original message. So this is how you would encrypt multiple files at the one time. So let's switch over to Bob's computer or terminal. We'll install the Python libraries here. We need root privileges for that. And then we'll create a file, gen key, similar to what we did on Alice's computer. And in the file, here's the code to generate the keys. It's all similar to what we did on Alice's computer. The only exception is that the home directory had to be changed to Bob. We're also going to export the keys on Bob's computer. So the public key is going to be export keys. And we know this is the public key we're exporting because if it was the private key, it would be export private keys. That's the command or the method. So here we're going to export the public key to a string, and then we're going to open up a file, Bob pub key, and write the public key to that file. So let's run this. So when we run this, we should create a file with Bob's public key. There's the fingerprint. We did the print statement in the code. And let's look at what's inside Bob's public key, and there it is. So now we just need to copy this to Alice's computer. We'll need the root privileges to do this because Bob doesn't have write access to Alice's home directory, and this is common in Linux. So now we'll flip back to Alice's computer or terminal. And we see that the file has been copied. Now we need to import Bob's public key into Alice's keychain. To do that, we'll write some Python code. We'll open up a file. And in the file, the first two lines should look familiar, and the third line will just read Bob's public key file into a variable called key data. Then we'll use the GPG import keys method with the key data as an input, and that will give us the instance import results. So this will effectively import the keys. The next step is we need to set the trust level for the keys, and in order we need to do this so that we can encrypt data with Bob's public key. If this step is not done, then we'll get an error when we encrypt. So the trust level we'll set is ultimate, which is the highest level. We're sure that this is Bob's key in this case. And then we'll also need the Bob's key's fingerprint, which is the shorter digit, alphanumeric digit of the key. So to get that, we'll use the import result instance and select fingerprints, and that'll give us the fingerprint of Bob's public key. So we'll put these two variables in, the trust level and the fingerprint, and that will set the trust level for Bob's key at the highest level. Finally, we'll use the myKey variable to get a list of the keys on Alice's machine, and this will show us that we've imported Bob's key. We can run this command in GPG on the command prompt, but we're doing it in Python. So when we print out myKeys, we should see a list of keys that are on Alice's computer, and this will confirm the import. So when we run this, we import the keys. And as you see from the printout here, we have both Bob's key now and Alice's key. This is Bob's public key. And then we have Alice's public and private key. So the import was successful. So now let's encrypt the file with Bob's public key that we've imported. So here we have the debug file that we used before. But as you can see, it's still plain text. We're going to encrypt that file with Bob's public key on Alex's machine or terminal. So we use the similar file, we just changed the home directory, and we're using pretty much all the same as we did before to encrypt the file. The only difference is that the recipient now is bob@acme.com. So the email ID is the UID, that's the identifier for the key. And then we're just going to add encrypted at the end of the file when we're done. So won't touch the original. And we have our usual standard error message at the end to ensure that everything encrypted. Okay. And it did. All looks well. So now if we go into the text files, we should see a encrypted. And there it is, and we'll cat that to see the encrypted text from that. There it is. So that was done with Bob's public key on Alice's machine. So Alice could not decrypt this file with her keys. That would have to be sent to Bob to decrypt with his private key. So let's go back to the example we had before where Bob sent Alice his public key and Alice encrypted a document with Bob's public key and sent it to Bob. Alice knows that only Bob can decrypt it because he has the private key. However, Bob doesn't know for definite that Alice sent the encrypted document because his public key presumably would be out in the wild and anyone could have sent it. So in the next section here, we're going to solve that problem by signing the document to ensure that when Bob receives the encrypted document for his public key, that he'll know that the document came from Alice. So to deal with this problem, when Bob sends his public key to Alice, Alice will first sign her document with her private key and then encrypt the signature and the document with Bob's public key. She'll send that to Bob. Bob will decrypt it with his private key, and then he will verify the authenticity of the file with Alice's public key. This is how we get around trust with exchanging encrypted documents. So for our signing, we'll actually create our own file here in the text file directory, just to keep things simple. And we use the echo command from Linux and save that to a file called plaintext Alice. I don't know why I keep saying Alex. So there's the file. And that's what we're going to encrypt and sign. Create another file to do this. And in this file, we have the home directory and the file. We'll have to change the plaintext, obviously, for signing. But stream here is the variable that opens the file. This is just another way of opening the file. So we're opening the plaintext Alice file and bringing it into bytes. And then we're going to get the fingerprint from that. And the way we're going to do that is with the GPG list keys method. And that will give us the fingerprints. The keys are listed in a list, in a Python list. And if we use 0 in that list, then that'll be the private key for signing. So that'll be Alice's private key. So when we do the list keys, it gives us a list of all the keys, but 0 is, in this case, and in most cases, will be the private key of the machine you're on. The true here means that it's the private key and not the public key. So when we do that, we collect that into a variable called edata. So we'll use the method GPG encrypt file, and then we'll put in the stream, which is the open plaintext file. The recipients then is Bob, because that's what we're going to use to encrypt it. So that's Bob's public key. So the recipients is for the encryption. The next one then was we're signing it with the fingerprint that we created for Alice's private key. And we also need the passphrase for Alice's private key. So this is a two-step process here in one line. We're going to encrypt the document with Bob's public key and sign it with Alice's private key. So now we'll run this file and that'll encrypt and sign the file that we created. No errors. I forgot to put the print statements at the bottom, but I presume it ran okay. But to verify, let's look at the file in our directory. And there it is with the GPG, PGP extension. So if we cat this, we should see an encrypted file. And there it is. So now we need to copy this encrypted and signed file to Bob's home directory so we can decrypt it and verify it there. Oops, we need root privileges, so we'll do that again. And it copied. So now we'll flip over to Bob's terminal. And there's the file. It's copied over successfully. So the next step would be to write some code to decrypt and verify that file. And here we have the standard code block. We changed the p-text or the plain text to the PGP. We're going to open the file as we did before, and we'll put the passphrase in because to decrypt the file first we need Bob's private key. So whenever we're using the private key we need the passphrase, assuming there was one supplied at the time of creation, which is highly recommended. And then we put the .verified extension to show these are the print statements that gives us some feedback onto the status of the decryption. We're going to put one more in here to show the trust level. So this will print the trust level of the decrypted data, and this should be the same as Alice's public key in Bob's keychain. And that should be ultimate. I believe that's what we set it to. So this will show us that this file definitely came from Alice. So when we run it, we get the decryption was okay, the file is valid, and the trust ultimate, meaning that this definitely came from Alice or was created by Alice's private key. It was signed by Alice's private key and encrypted by Bob's public key. So there's the original text, so it was decrypted successfully. So that's a pretty complete review of the main functions of the GnuPG library in Python and using it with PGP. There are other things you could do, but this covers the basics that we set out to do. We've generated the keys, we've encrypted with our public key, decrypted with our private, we've imported keys from other users, signed the document, and verified the document. So they're the core functions of a PGP. So you can use this in your scripts or in your applications to manage encryption of data and the exchange of keys in Python. So the code for all of this video will be on my GitHub site at the link below. If you like this video, please don't forget to like, share, and subscribe. Thanks again for watching, and I'll see you soon.